Hi everyone, you're welcome to my YouTube channel, City of Electrons. And in this video, we are going to talk about this, a computer. How can a computer communicate with other computers? Okay, maybe other computers, two or more. Okay, now, if all you want to do is inside a single computer, and all you need to do what you want to do is still inside that single computer, well, then you don't really need to communicate with others. It's no longer a need, because all you need is inside here, and all you want to do is inside here, so you just do it here. Now, if there is a need to communicate with other computer, okay, you need to communicate with other computer, maybe to share file or share resources or things like that. If that need arise to communicate this computer to send data to this other one, or information to other one, or share resources, now because of that need of communication, that means we need also to talk about rules for these guys to communicate. They cannot just communicate anyhow, like, okay, there need to be rules, guidelines, rules for communication, rules for what? Engagement. This laptop engaging or communicating with the other laptop, there need to be rules. Laptop, computer, same idea. Okay, so those rules are known as what? Protocols. Those rules are known as protocols. So that's what we are hitting on today. Protocols. Protocols are what? Rules of engagement. Okay? The need for protocols is due to the fact that computers were stand alone at first. When computers had to communicate with other computers, then arose the need for rules for computers to what? Communicate. The rules of their engagement is known as what? Protocols. Exactly what has been explained right here. Okay? Exactly what has been explained right here. So I hope that's clear. Now, the next thing is this. Now these rules, who set up these rules? Who give these rules? Who is in charge of all this? Okay? Now, that's the IEEE. Okay? Institute of Electrical Electronics Engineering. They are the ones in charge of this what? Of rules like this. Okay? They make the rules. So IEEE set standards for network communication. There are two, okay? Two common standards are what? 802.3 and what? 802.11. The 802.3 is the Ethernet. And then this other one is the what? Wi-Fi. Okay, now, although, now this, please, note that all we're talking about now is from our first class in EEE 534, our first class there. Okay, and it's kind of an introduction. Okay, so after the lecturer made mention of this, we kind of zoom in into this particular one. Okay, which is Ethernet. So Ethernet was originally invented by who? By Xerox in the lab, but of course the standardization of it was done by IEEE. Okay, so the Ethernet was originally invented by Xorex in the lab. Now, amongst the communication elements in the Ethernet, please, before I continue, note this. What we're talking about is this. Protocols is what we're talking about, right? Protocols is what we're talking about, right? Protocols. So these are the rules of engagement. Rules of engagement. Now, this is it. These rules, the set of rules for engagement, one set is called what? One set is called what? Ethernet. Do we get the idea? So Ethernet is an example of a protocol. Do we get it? Protocols are rules for rules of engagement. So set of rules. I just hope we are getting what I'm trying to say here. Set of rules, yes, for engagement. Set of rules. Okay, so when you pack some set of rules together for engagement, those rules, one of the examples, collection of rules, they now gave it a name, Ethernet. Do we get it? Collection of rules, one of the examples is what? Ethernet. So Ethernet is a set of rules for engagement, or set of rules of engagement. It's the same thing as protocol, just like protocol has been defined. Okay, give us an example. One, Ethernet. Do you get the idea? So that's that. Okay. Now, amongst the communication elements in the Ethernet standard exists CSMA/CD. That is Ethernet. Ethernet now, it has elements. It has things that makes it work. We just said that Ethernet is an example of protocol, right? Now, as Ethernet as an example of protocol, it has things, combination of things, combination of elements that makes Ethernet work. Now, one of those elements, okay, is what? CSMA/CD, where CS means what? Carrier sensing. MA means what? Multiple access. CD means what? Collision detection. Okay, then of course introductory class, so I'm not really going deep into them. Now, the other thing that the lecturer said was a network has multiple systems, computers, okay, and each system has a network card in it. Now, the network card has their own what? Unique port address for each system. Now, what does this mean? What does this mean? First, I think I should show us the Ethernet cable. I have it somewhere. Yeah, right here. Right here. So, now look at the Ethernet cable now. Okay, and where you plug the Ethernet cable to in the system. Now, what is being said in this paragraph, or the paragraph I just read, is that each computer has what? A network card. And that network card has a what? A particular port address. So that port address is used to identify a computer. The port address of this computer will be different from this port address of this computer. So how to communicate with a computer? You need its own port address. Do we get it? So if you know the port address of a computer, you can actually connect with that computer. When browsing, IP address is what's made mention of. So when you say IP address or port address, you are kind of talking about same idea. Okay. Now, Ethernet is one example of a protocol. I've said that already. Another protocol is what? The OSI protocol, where O stands for open, S stands for system, and I stand for what? Interconnect. So look at this picture here. It will show you the OSI model. Okay, OSI model. So we just said that we've defined protocol. We've given an example of protocol, one of them being Ethernet, and then another example here is the what? OSI model, open system interconnect, OSI model. So OSI protocol, sorry, but this is the model, how OSI looks like. It has 7 layers: 1, 2, 3, 4, 5, 6, 7 layers. The first layer, that's from bottom, you have what? The physical layer, you have data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So this is just the summary of what was said in the last class. So yeah, that's it. The idea of protocols, examples of protocols, those are set the protocols, and then the fact that each computer has a specific network card and a unique port address, and then the OSI model. And yeah, for this this other part, the lecturer made mention of the first layer, okay, which is the physical layer. And he said the physical layer involves twisted pair cable, coaxial cable, optical fiber, and then free to air microwave link. These are just the physical layer, these are just ways we can receive data. Okay, baseband signal comes in at the what? Physical layer, and it comes in through where? Either a twisted cable, either coaxial cable, either optical fiber, or free-to-air microwave link. Now, when our baseband signal comes in at the physical layer, this signal goes through analog to digital what? Converter. Okay, so that's just where we stopped in the last class. So that's that for now. Thanks for watching, and leave questions in the comment section. Like, share, subscribe, and I'll see you in the next video. Bye for now.